Welcome back to the AI Explained MENA Perspective series. In our second episode, we're going to dive into the heart of AI, the data. You've likely heard of the phrase, AI is just software written by data. Well, that's true. Today, we'll explore what that really means, covering data collection, utilization, and the critical issue of bias in AI. So let's get started. Data is the foundational building block for AI. By leveraging vast volumes of data, AI can uncover patterns, trends, and correlations that might otherwise go unnoticed by humans. But where does all this data come from? Well, there are many ways. For example, sensors collect real-time data from the physical world. Devices like smartphones, Internet of Things gadgets, and industrial equipment also gather information on movement, temperature, light, and sound. Additionally, our digital footprints generated from our online interactions, transactions, and general behavior across all social media platforms provide insights into user preferences. We also have extensive public and private databases, from healthcare records to financial and demographic data maintained by governments and organizations. Also, crowdsourced data, like reviews and user-generated content, plays a significant role. In fact, humans generate a whopping 2.5 quintillion bytes of data every day. For reference, 1 quintillion second is the equivalent of 32 billion years. And remarkably, 90% of this data was created within the last 3 years alone. That said, the quantity and quality of data are both crucial. More data can enhance AI's robustness and accuracy, while high-quality data ensures reliability and meaningful results. High-quality data is accurate, consistent, and reliable, boosting AI efficiency and enabling valuable insights even from fewer data points. In AI, we use training data and testing data. Understanding the distinction between testing and training data is fundamental to grasping how AI models are developed and evaluated. Training data builds the model, allowing it to learn from patterns, and testing data, on the other hand, evaluates the model's accuracy on new, unseen data, ensuring it performs well in real-world scenarios. Typically, data is split into 80% for training and 20% for testing. Now let's address a very critical issue, bias in data. Biases can creep into data in many forms, often going unnoticed and causing machine learning models to adopt those biases. Bias can be caused by different reasons and can manifest in several ways, including training data bias, algorithmic bias, and cognitive bias. Training data bias occurs when the data collected doesn't represent the entire target population, leading to skewed results. This is commonly seen in facial recognition systems that misidentify people of color if trained predominantly on images of white individuals. In Egypt, many local companies like Synapse Analytics address misrepresentation in datasets. Their Ask a Vision team, for example, very early on encountered a problem where veiled women were often misclassified and misgendered as men due to biases in publicly available datasets, which primarily featured non-veiled individuals. This issue mirrored broader biases in datasets, such as Fairface, where class representation was imbalanced, particularly regarding gender and race. By rebalancing class representation, Ask a Vision was able to mitigate this issue. A second type of bias is the algorithmic type. Algorithmic biases happen when flawed algorithms disadvantage certain groups due to underrepresentation in training data or societal biases, perpetuating existing biases and social inequalities. This type of bias can impact crucial areas like healthcare, justice, and even finance. Finally, cognitive bias occurs when data selection is influenced by personal experiences and preferences. For example, this occurs when datasets from the US are favored over a global range. This happens because human biases can enter AI systems through data selection and weighting, reflecting the developer's experiences and preferences. The consequences of biased data in AI systems are significant. It can lead to unfair treatment, amplify social inequalities, erode public trust, and even pose legal and ethical challenges. For example, biased hiring algorithms may favor one demographic over others, leading to unequal job opportunities. And in areas like healthcare, biased data can lead to ineffective treatment for underrepresented populations. To mitigate bias, robust AI governance is absolutely essential. We need diverse and representative data, actively including data from all relevant groups. Bias detection and correction techniques are crucial. By using tools and statistical methods, we can identify and fix biases. Ensuring AI models are transparent and accessible helps in recognizing bias sources, while continuous monitoring and updating AI systems improves their ability to adapt to new biases and societal changes. In short, ensuring compliance with regulations, incorporating human oversight, and continuous monitoring is key. We need diverse and representative data to help create fair and trustworthy AI systems that are beneficial to everyone.